Assalamualaikum and hi to everyone. Thank you for watching this video. So this video we continue on another part of chapter 3 about the processes. So we talk about the interprocesses IPC. So the objective for the part 2, we already learned about the process concept, the scheduling, the operation on the processes. So the next part we go for the interprocess communication, the IPC, and then we look for the IPC system, the example of IPC system. And then the last part is about the communication in the client server system. The objective for this part is to introduce the notion of a process in a program in execution, which form the basis of all the competition. And then describe the various features of the processes, including the scheduling, creation, and termination communication that we already discussed in the part 1. And then to explore the inter-process communication using the shared memory and the message passing, we will discuss later on. And to describe the communication in the client-server system. So let's go to the part of the IPC, inter-process communication or IPC. So this process is within the system. Processes within the operating system may be independent or cooperating or dependent. So we have two types, independent and dependent. So dependent process can affect or be affected by other processes, including the sharing data. Means it depends on other processes. Independent process does not affect by others and does not affecting the others. So we have to find dependent and independent. So dependent, we also call it the terminology using cooperating. Cooperating. So the reason why we provide is the reason why we have this kind of cooperating processes, or what we say, the reason why for providing this kind of environment that allows the process of dependent. This depends on these four reasons. First is about the information sharing. Okay, we have more than one users, and several users may be interested in a piece of information. Okay, let's say you have one file, so several users may interested to access to that file. Okay, that's why you provide the environments that allow the concurrent access or simultaneous access to that information. The next part is about the competition speed up. Okay, to speed up the process, okay, if you want to that task can be run in a faster way, okay, we must break it into several tasks. So each can be executed in the parallel way, in simultaneously. So the process may be speed up more faster. Okay, you can look at your laptop or your PC. Okay, we have the processor, and currently our processor we have the term dual core i9 i11, okay, because we want to speed up the process. And then the third is about the modularity. So this part is about the construct the system in the modular fashion, that dividing the system function into processes or thread. So this one about the spread processes, and that we already discussed in chapter 2 about the modularity. And then the fourth is about the convenience. Okay, convenience means that as a user, you as the user, when you do individual, if you do your assignment, for example, you open the Microsoft Word, in the same time you want to listen to this music, right? So to make you convenient as a user, so we allow the simultaneous processes in the same time. So that's the reasons why uh, the process cooperation or dependence process being introduced or exist. So the cooperating process, it's require a inter-process communication mechanism. So this IPC will allow them to exchange the data and the information. So in order to uh, exchange data and information, okay, interprocess communication, which is referred to the IPC, have two type of model. The first one is shared memory, and the second one is message passing. Okay, the IPC have two model. The first one is shared memory, and then the second one is the message passing. I believe you already heard about the message passing before this. Okay. Uh, okay, look at this diagram. So diagram A is referred to the message passing, and diagram B is referred to the shared memory. So look at the diagram. Okay, in message passing we have process A, and then we have process B, and then we have the message queue, because this one is message passing. So both process give the message. So it's exchange the message in the system kernel. So data is shared between the process by passing and receiving. So one process passing and then another process receiving. So these are the how message passing done between each processes. Okay. If you look at the shared memory, we have process A and we also have process B. And then we have one part for the shared memory here. So process A will use the same memory that being used by the process B. And then this model doesn't involve the kernel system. So in the shared memory model, okay, a region of memory that is shared by the cooperating processes is established. Okay, refer to the diagram. We have the shared memory part. So the processes can then exchange the information by reading and writing the data to the shared region. So process A will read and write to the shared region. Process B also do the same thing. Okay, look back at the diagram A. In the message passing model, communication takes place by the message exchange. So that's are the difference between the shared memory and the message passing. Okay, next we go for comparison. Okay, we look at the shared memory first. Okay, shared memory communication is faster. The message passing model faster than the message passing model when the processes are on the same machine. Okay, how about the weakness? Different processes need to ensure that they are not writing the same location simultaneously because they share the memory. So they must ensure that when they do want to writing, they are not write in the same location. Otherwise, your system will be confused. Okay. Another point, processes that communicate using the shared memory need to address the problem of the memory protection and synchronization. Okay, so these are based on the shared memory. It's more faster because it you can refer back to the diagram B. Okay, this one is more faster because they don't need to do exchanging message from one to another. Okay, now let's look for the message passing model. So this model is easier to implement than the shared memory. This one is easy to implement because it just pass the message. How about the drawback? Communication using the message passing is slower than the shared memory because it involves the time in order to set up the communication. If you learn about the network, before you communicate, you must do the establish or create the communication between two parties, and then after that you can do uh, the handshaking operation. So later on, if you learn, I believe you already learned on the network part. So the process of establish the communication may affect the uh, the speed. So it affect the speed compared to the shared memory. Okay. Independent process cannot affect or be affected by the execution of another process because it is independent. It can work alone. Okay. Uh, it can work alone. It's more on standalone process. A cooperating dependent process can affect or be affected by the execution of another process, means that you will never work alone. Okay, they need someone to integrate. Okay. So advantages of the process cooperation: information sharing, the competition, speed up, modularity, and convenience. Okay, the explanation I already explained in the previous slide. So they are uh, the dependent and dependent process of the uh, system. And then we have go for the shared memory, and area of the memory shared among the processes that wish to communicate. They need to establish or create that memory shared. And then the communication is under the control of the user processes, not the operating system. And under the shared memory, major issue is to provide the mechanism that allow the user processes to synchronize their action when they access the shared memory. Okay, synchronization is important when they do the shared memory. So we will look later on about the synchronization in chapter 5. Okay, in message passing, uh, this is the mechanism to communicate and to synchronize their action, means between processes that already runs. We have the message system. So in the message system, process communicate with each other without resorting to the shared variable. And the inter-process communication facility provide two operations that we call as the send and receive. So each process will interact using the send and receive function. And the message size is either fixed or variable, means fixed the length or It can be dynamic. Okay. In message passing, if processes P and Q wish to communicate, they need to first establish the communication link between them and exchange the message via send and receive function. If they want to communicate, then they need to establish the communication links. So that's why it's more slower compared to the chat memory. So how about the issues? Okay, issue is about the how are the link established? Can the link be associated with more than two processes? And let's say we have process A, B, and C. A need to establish the communication with B. A also need to establish the communication of C with the C. Okay. So the issue here, can a link be associated for more process? Mean we just create one link. So A can communicate with B. A also can communicate with C. Okay, another issue. How many links can be there? Okay, between every pair of communication processes. What is the capacity of the link? Is the size of a message that link can accommodate fixed or variable? And is a link unidirectional or bidirectional? That's the issue if we talk about the model on passing the message. Okay. About the implementation of communication link, we have two parts. The first part is about the physical, and then we have the logical implementation of communication link. So for the physical is we have the shared memory, the hardware bus, and network. For the physical, for the logical, we have the direct or indirect, and synchronized or asynchronous, automatic or explicit. The bufferings mean time taken before we can proceed to another, so it has a buffer, but like a delay. Okay. Next, about the direct communications. So processes must name each other explicitly, then receive. So send message to P process, receive message from Q process. Mean it must have the the source and the destination. So easy to communicate. And then properties of the communication links. Link should be established automatically, associate with the communication pair, one pair of the communication processes, and between each pair there exists exactly one link. This one for direct communication, just like peer-to-peer communication in the network. And the link may be unidirectional, but it usually bidirectional. Means one goes to, let's say we have A and B, A goes to B. So only unidirectional. If bidirectional, A can go to B, B can go to the A. Okay. That is about the direct communication. Next, we go for the indirect communication. So messages are directed and received from the mailbox. So this one also referred to as a pod. And each mailbox has a unique ID. So easy to identify the source and the destination. And processors can communicate only if they share a mailbox. It's one indirect communication, so it use the mailbox. So properties of the communication link. Link established only if the processors share a common mailbox. So we can have the communication link. A link may be associated with many processes. Each pair of processes may share several communication links, and link may be unidirectional or bidirectional. So you have two communication. The first is about direct communication. Second is about the direct communication using the mailbox. Okay, operation for the indirect communication. First, you need to create a new mailbox or port for the process, each process, and then send and receive message through the mailbox. Okay, it's not direct from A to B, B to A, but it's through the mailbox, and then destroy the mailbox. So in communication, we have create and then do the communication, and then we need to terminate the communication. And then primitive are defined as send a message means that send a message to mailbox A, receive message from mailbox A. So this is the difference between the direct and indirect. Okay, for mailbox sharing, okay, let's say we have three process 1, process 2, and process 3. So we have P1, P2, P3. So this process will share the mailbox A. So process 1 sends, process 2 and process 3 receive. 2 will get that message. Process 1 send, so process 2 and 3 need to receive. Okay, so allow a link to be associated with at most 2 processes, and then allow only one process at a time to execute a receive operation, and allow the system to select the arbitrarily the receiver, and sender is notified who the receiver was. Let's say we have this kind of situation. So these are the solution for the indirect communication. Next, about the synchronization. Okay, message passing may be either blocking or non-blocking. So blocking is considered as the synchronous. Blocking send, so the sender is blocked until the message is received. Blocking receive, the receiver is blocked until the message is available. Means that we use the blocking in order to apply or implement the synchronization. Okay, for non-blocking, so we consider it as asynchronous. Okay, so we have synchronous and asynchronous. Non-blocking send, the sender sends the message and continue. Okay, and non-blocking receive, the receiver receive a valid message or null message. Okay, these are the difference between the blocking and the non-blocking. When we use the blocking send, so the sender is blocked until the message is received. So in that time, the sender cannot send to another receiver. Okay, so the sender send the message and continue sends. There is no block. So that's why we call as asynchronous, and another part we call as synchronous. So different combination possible. If the both send receive are blocking, we have render off. So end of part 2. So basically they are about the IPC and the model about the IPC in the chapter 3. Okay, you learn about the direct communication and indirect communication. So direct communication, one process communicate to another process using a dedicated link. We call as dedicated link. If we talk about the indirect message, so they use the mailbox mechanism. So anything go through the mailbox. So you need to receive from the mailbox and send from the mailbox. Okay, so that's all for chapter 3. So end with the inter-process communication. I'm sorry because subtopic line answer were already deleted from this topic. So chapter 3 only until the inter processes communication. So that's all for this video. Thank you and assalamualaikum.